Hello, everyone, and welcome to What's Up, the podcast where we talk about everything electrical and the future of test and measurement. My name is Darcy, and I'm here to dive deep into some of the biggest topics in our industry. Today's guest is Dr. Ahmed El-Rashid. He is currently an industry director for Megger, and his work has spanned multiple industries and seen him contribute to several notable papers. Today, we are talking about one of the biggest challenges in asset management, which is unplanned downtime. So let's find out what's up with Dr. Ahmed El-Rashid. Dr. Ahmed El-Rashid, thank you very much for joining us today. How are you?
I'm very good, thank you. Thank you for having me.
No, our absolute pleasure. Now, the way we usually start this podcast is by doing something we call the Power Up. It's 3 questions just to kind of get your brain in gear. Are you ready for them?
Excellent, let's do it.
Okay, first question. What is your current job role?
My current job role with Megger is Director of Business Development.
Great. And you have a PhD. What was it on?
Yes, I gained a PhD out of the University of Liverpool in the UK. It was sponsored by Jaguar Cars. And what I did is I developed artificial intelligence to integrate multiple sensors to provide decision-making during the production of a car. So if something needs to be reworked, the computer automatically will say, that's not right.
That sounds pretty cool, pretty glamorous for a PhD.
Yeah, it's not bad.
And what was the last paper you published?
I published a paper just last year at the Seeger conference on monitoring of large rotating machines using the latest partial discharge testing techniques.
Great. So today we are here to talk all about the industrial market. So in your opinion, why is it important that the test and measurement industry really pays attention to the industrial market?
Well, the industrial market is the figurative workhorse of modern life. Everything we buy, food and stuff like that, is coming through a food processing plant. The paper we write on is coming from a paper mill or something like that. And that industry is constantly looking for ways to improve efficiency, to reduce losses. And when they do that, they can pass to the consumer some cost reductions. And the test and measurement industry is very well placed to help with that task for the industrial market.
So unplanned downtime, I guess, can have a huge impact on maintenance and asset managers. So how big of an impact does it really have?
It can be quite significant. I was with service engineers who worked in the oil and gas industry. And maybe this is kind of an extreme industry because they do make an awful lot of money. But what he told me is if they lose production out of a well, and this is a company based in Texas, he said for them the cost of lost production can amount to between $20,000 to $25,000 per minute.
Wow, that is huge.
Absolutely huge. So for them, unplanned downtime is an absolute nightmare. They cannot afford it.
It's almost a non-negotiable. Like it just can't happen, right?
Cannot happen. No.
So you've been in the industry for quite a while. You're very experienced. So do you have any examples you could share with us about like how disruptive this could be?
Absolutely. I'll give you another kind of story just to illustrate it. We were working with a paper mill company, quite a well-known one based in the southern states in the U.S. And they have multiple paper mills across the southern U.S. And they were calculating how much the cost of downtime was for them in the previous year. And it was running in the tens of millions of dollars.
Wow.
So they hired an engineer to investigate this and find out what is the actual cause, what is the problem, and how can we then solve it. And what he came up with is that the majority of the problems were electrically related. The biggest culprit was motors going either losing power or just not turning on or cutting out in the middle of production and causing a nightmare. So they came to us, Megger, to help them with test and measurement of their motors and their electrical assets in order to make sure that they can avoid all this downtime. Now, a paper mill, unlike the example I gave with the oil and gas, unplanned downtime for them cost around $10,000 per minute.
It's still an expense.
It's still huge.
Yeah.
It's still
not
absolutely
quite the
huge.
millions and thousands we had before,
But it is quite significant. So we worked with them to develop a testing plan that they can do during their planned downtime. So they had, if I remember correctly, around 20 planned days per year of downtime for that, for each one of their sites, each one of their plants. During that time, we helped them figure out a way to go and test both their cabling, their interconnections, and their electrical motors. And we had like a trial period of about 6 months to see how it's kind of going before they kind of implement that, company-wide.
Mm-hmm.
During that 6 months, we, during the planned downtime, we discovered problems in motors. Some were really critical motors that, that one motor going down, that shuts down the whole plant. Using testers that employ testing techniques like the Baker test, which is the surge insulation test. Mm-hmm. They managed to, in that particular motor, the really critical motor, they managed to find phase-to-phase insulation weakness. So before the motor actually went down, doing the testing on multiple planned down times, you can see it progressing worse and worse.
Yeah, you can see it weakening, right?
And they're like, okay, let's get a new motor in to replace it the next downtime, and then we can work on actually fixing that. And by doing that, they didn't have any shutdown during those 6 months. The engineer that was working on it, he just looked at the site that we were working on, and he said, well, the things that we managed to repair, the things that we discovered before they did go bad, they could have cost us up to $3 million over that 6 months in lost production.
Yeah.
So regular testing, preventative testing, it really pays dividends if you do it, and you do it during that planned downtime.
I was going to say, like, it could have a huge impact, like no matter how big or small kind of the area is or the industry is. So Absolutely. If you were a maintenance manager, from a practical perspective, what could they do to ensure that, unplanned downtime goes down to a minimum? Now,
every situation is a little bit different,
for sure,
but there are some general principles that we recommend. We recommend that the maintenance manager assesses all the different assets that they have, and then during the planned downtime, make the most use of that. Normally, if you've got a planned downtime, a particular day, the factory's not going to be working, well, the maintenance team needs to be working double time.
Yeah.
They need to know what their critical assets are, have the right testing tools, have the right testing program, and then go through that whole plant, that whole site, and make sure that everything is doing well. And if they're employing preventative testing techniques, that way they can spot problems before they actually become an actual fault, and plan for that.
So having a really robust and comprehensive kind of schedule of maintenance is very important, I guess.
It's absolutely key. And that's how you can reduce, in fact, done correctly, eliminate unplanned downtime.
Yeah, sure. So although kind of, routine maintenance is very commonplace, the test and measurement industry is always evolving. So do you have any recommendations for any kind of like resources or where people can go to maybe delve a bit deeper into this topic?
Absolutely. On the Megger website, we've got a technical library, a kind of a learning corner within it. I recommend a particular document is the Baker Motor Test Theory booklet. It goes through all the different types of tests you do with rotating machines in particular, and preventative testing. There's obviously an awful lot more, but that's a good place to start, and it'll lead you in the right direction.
Perfect. Well, thank you so much for coming in, Ahmed. I really, really appreciate it. I hope you've enjoyed it too.
Yeah, this is great. Thank you very much for having me.
Cool, no problem. Thank you for watching and listening.